Now related to freely falling body, we take some problems. A ball is dropped from the top of a building 19.6 meters high. Find the time taken by the ball to reach the ground. Now what is given in our problem? This is a building of height 19.6 meters. From the top of the building, a ball is dropped. When it is dropped, what is initial velocity? Yes, u equal to 0. And what is the acceleration? A equivalent to g, which is acceleration due to gravity, and this is equal to 9.8 meter per second square. We are asked to find the time taken by the ball to reach the ground. In problem we are having u, s, a. We want time. Now we can apply the equation s is equal to ut plus half at square. In this problem, u is 0, s is equal to 19.6 meter and a equal to 9.8 meter per second square. And substituting all these values, we get 19.6 is equivalent to 0 into t plus 1 by 2 into 9.8 into t square, or 19.6 is equal to 1 by 2 into 9.8 into t square. From this, t square equivalent to 4, t equivalent to 2 seconds. That means a body which is dropped from a height 19.6 meters takes 2 seconds to reach the ground. Now we take another problem. In above problem, what is the velocity of the ball just before reaching the ground? In this problem, we have to find what will be the velocity just before reaching the ground. That means we have to find the velocity after displacement 19.6 meters. We know initial velocity for a freely falling body, it is 0. Acceleration of the body is nothing but a equal to g. This is equal to 9.8 meter per second square, and the displacement it traveled 19.6 meters. We have to find the final velocity. Which equation relates these four quantities? Yes, you are correct. V square minus u square equivalent to 2as. In this equation, u equal to 0, a equal to g. Then we get v square equivalent to 2gs, or v square equivalent to 2 into 9.8 into 19.6. Then we get the velocity is 19.6 meters per second. Therefore, the velocity on reaching ground is 19.6 meters per second. Now we take another problem. In above problem, what is the time taken to fall half of the maximum height? How much time it takes to fall complete height? Already we done this. It is 2 seconds. Now what is the time taken to fall half of the maximum height? Can we take it is 1 second? No or yes? Let us check this. We have to find what is the time taken to fall half of maximum height. That means the displacement is 9.8 meter, initial velocity is 0, and a equal to g, that is 9.8 meter per second square. To find time, again we take the equation s is equal to ut plus half at square. 9.8 equal to 1 by 2 into 9.8 into t square. We are getting t equivalent to root 2 seconds. One thing you observe, it is not 1 second, it is root 2 seconds. That means in general, the time taken to fall half of the maximum height, that is h by 2 equal to 1 by 2 gt square, that is t1 is root h by g if the ball is falling from height h, and to fall complete height, that is to reach the ground, h is equal to of gt2 square, where t2 is the time taken to reach the ground, we get t2 equal to root of 2h by g. And the relation between t1 and t2 is t2 equal to root 2 t1. Now we take another problem. A ball is falling from height 78.4 meter. What are the distances covered during successive intervals of time? Now what is given in our problem is a ball is falling freely from height 78.4 meter. We are asked to find what are the distances covered during successive intervals of time. The displacement covered in nth second for a freely falling body is given by Sn equal to g into n minus 1 by 2. If n equivalent to 1, that is the displacement during first second, S1 equivalent to g into 1 minus 1 by 2, substituting n equivalent to 1, this we get g by 2. On simplification, we get S1 is 4.9 meter. If n equivalent to 2, that is the displacement covered during second, S2 equivalent to g into 2 minus 1 by 2. Instead of n, we are substituting 2, and this is equivalent to 3g by 2, or S2 equivalent to 3 into 4.9, 14.7 meter. And S3, the displacement covered during third second, this is g into 3 minus 1 by 2, and this is equal to 5g by 2. Then S3 equivalent to 5 into 4.9, this is equivalent to 24.5 meter. And S4, this is equivalent to g into 4 minus 1 by 2, and this is equal to 7g by 2, or S4, this is equal to 7 into 4.9, this is equal to 34.3 meter. That means when it is falling from height 78.4 meter, during the first second, it travels a distance 4.9 meter. During the next second, it travels a distance 14.7 meter. During the third second, it travels a distance 24.5 meter. During the fourth second, it travels a distance 34.3 meter. Now in our problem, what is the ratio of distances covered in successive intervals of time? That is, we require the ratio of S1, ratio S2, ratio S3, ratio S4. This is nothing but g by 2, ratio 3g by 2, ratio 5g by 2, ratio 7g by 2. And this we get 1 is to 3 is to 5 is to 7, etc. In general, if a body falls freely for n seconds, then the ratio of distances covered in successive intervals of time are S1 is to S2 is to S3, etc. up to Sn. This is equal to g by 2, ratio 3g by 2, ratio 5g by 2, ratio 7g by 2, up to n minus 1 by 2 into g. And this ratio we get 1 is to 3 is to 5 is to 7, and the last term is 2n minus 1. Or we can say Sn proportional to 2n minus 1. And one more important thing we have to observe in this problem. The displacement covered in first second is 4.9 meter. The displacement covered in second is 14.7 meter. What is the difference between these two? Yes, 9.8. Similarly, the displacement covered in second is 14.7 meter. The displacement covered in third is 24.5 meter. What is the difference between these two? Yes, it is also 9.8 meter. Similarly, the difference between the displacements covered in fourth and third is 9.8 meter. Then what you can conclude? If a body falls a distance x during nth second, then in next second it falls at distance x plus g. And in previous second, what was the distance? The distance traveled by the body is x minus g. That is, suppose if I consider this interval during third second, this is 24.5 meter. The next second, that is fourth second, if you add 9.8 to this, you get 34.3 meter. For the displacement in the previous second, you subtract 9.8 from 24.5 meter, then you get 14.7 meter. Now we take another problem. In above problem, what is distance covered after successive intervals of time? For a freely falling body, the displacement after t seconds is given by s is equal to half gt square. If t equivalent to 1, we get s1 equivalent to 1 by 2 into g into 1 square, or this is g by 2, this is equal to 4.9 meter. Similarly, if t equal to 2, just to substitute t equal to 2 in this equation, we get s2 equal to 1 by 2 into g into 2 square, or this is equal to 4g by 2. This results in 19.6 meter. T equal to 3, then S3 is 1 by 2 into g into 3 square, which is 9g by 2, which is 44.1 meter. If t equal to 4, S4 equivalent to 1 by 2 into g into 4 square, which is 16g by 2, this is nothing but 78.4 meter. That means, suppose we consider this, the displacement during first second is 4.9 meter and the displacement after first second is 4.9 meter. The displacement during second second is 14.7 and the displacement after 2 seconds from starting, this is nothing but 4.9 plus 14.7, which is 19.6 meter. Like this. In general, the ratio of displacements covered after successive intervals of time for a freely falling body are S1 is to S2 is to S3, etc. This is equal to 1 is to 4 is to 9 is to 16, and the last term is n square, since the displacement after t seconds is directly proportional to t square. We take another problem. A ball is falling freely from height 78.4 meter. After 2 seconds, if the gravitational forces cease it to act, with what velocity the body reaches the ground? Now what is given in our problem? A body is falling freely from height 78.4 meter. It is falling means because of gravitational force it is falling down. And after 2 seconds, the gravitational forces disappeared. Then what happens to this body? Can it reaches the ground or it stays there itself? What is your answer? Yes, because of the acceleration during 2 seconds, it gets some velocity. Even though the gravitational forces disappeared due to the property of inertia, the body will continue with the same velocity to the ground. Suppose in the same problem, when you just drop the body and gravitational forces disappear, then at this position there is no gravitational force. That means acceleration is equal to 0. In this case, the body will remain there itself. But in this case, during 2 seconds, it gets some velocity, and due to that velocity, with that velocity, the body reaches the ground. Now after 2 seconds, the velocity is v equivalent to g into t. This is equal to 9.8 into 2. This is equal to 19.6 meters per second. And in these 2 seconds, the distance travelled, this is given by equation s is equal to 1 by 2 gt square. Now this is equal to 1 by 2 into 9.8 into 4. This is equal to 19.6 meters. In 2 seconds it falls for 19.6 meter and the remaining distance is 78.4 minus 19.6, that is 58.8 meter. This distance it covers with velocity and 19.6 meters per second. Now the time taken to cover remaining distances t equivalent to distance by velocity, that is 58.8 by 19.6, we get this is equal to 3 seconds. Now what is the total time of fall? For this it is 2 seconds and for this it is 3 seconds. Total it is 5 seconds. Suppose the gravitational force is not disappear. In how many seconds it reaches the ground? Yes, it is in 4 seconds. Already we done this. Now we go for another problem. A stone is dropped into a well of depth 78.4 meter and splash is produced when it touches the water. After what time the person who dropped the stone can hear the sound? Velocity of sound in air is 313.6 meters per second. Now what is given in our problem? This is well, the depth is 78.4 meter means the water is at a depth of 78.4 meter. A person is dropping a stone from this position. The stone is a freely falling body. When it reaches the water, a splash will be produced. The splash of sound is heard by this person after some time. We have to calculate after what time he receives the sound. When he drops the ball, it takes some time to reach the water. Again, the sound takes some time to reach him from water. This total time is the time after which the person can receive the sound. Now the time taken by stone to reach water. It is a freely falling body. This we can find using equation S is equal to ut plus half at square. In this case, S is 78.4 meter, U is 0, A is acceleration due to gravity, that is 9.8 meter per second square. Substituting these values, we get 78.4. This is equal to 1 by 2 into 9.8 into t square, and t1 equivalent to 4 seconds. Now the time taken by the sound to travel a distance 78.4 meter is, in this case, sound is moving with constant velocity. Therefore, time is equivalent to distance by velocity. This is equal to 78.4 by 313.6. This we get 1 by 4 seconds. The time after which the person can receive the sound is 4 plus 0.25. This is equivalent to 4.25 seconds. Now we take another problem. A body falling freely from certain height covers a distance 7 by 16 of the total height during the last second. Then from what height it is falling? Now what is given in our question is, a body falling from height h covers a displacement 7 by 16 h during last second of its fall. We have to find from what height it is falling down. In case of a freely falling body, the displacement covered in t seconds is given by S is equal to half gt square. If we consider the body falls for n seconds, this we can write S is equal to 1 by 2 g n square, and this is equal to h, and the displacement covered during nth second, this is given by Sn equal to g by 2 into 2n minus 1. This is equal to 7 by 16 h. Why? Because the displacement covered in last second is 7 by 16 h. Now if I take the ratio of these two quantities, we get g by 2n square divided by g by 2 into 2n minus 1. This is equal to 16 by 7, or n square by 2n minus 1. This is equal to 16 by 7. If you solve this equation, we get n equivalent to 4. That means the body falls for 4 seconds. Therefore, the height from which it is falling is S is equal to half gt square. Here t is 4 seconds. S is equal to 1 by 2 into 9.8 into 4 square. This is equal to 78.4 meter. Therefore, the body is falling freely from a height 78.4 meter.